Good afternoon. My name is Andrew Schofield, and I come from IBM's Hursley Park Laboratory in Hampshire. And I'm going to talk to you about creating event-driven microservices. So most customers I talk to say, we're really going to do a microservices architecture. You know, microservices are the way. And they rarely kind of do the whole thing properly, but everyone's kind of talking about it. And I'm not going to go into a lot of depth about what they actually mean. I just want to kind of need a summary to start with. So it's essentially a technique for structuring your application as a collection of little services, and they're all kind of self-contained. And they're loosely coupled, talking over a network, but the key thing is they're independently deployable, scalable, maintainable, and testable. So this is a rather silly kind of primary school kind of diagram, but it kind of illustrates it quite well, I think. You've got all these different things kind of with their fingers in each other's objects, essentially in the data store, and what you're aiming for is essentially the thing on the right over there. So all the green things are together, all the red things, and all the purple things, and there are defined interfaces between these. So this is kind of the monolithic world, which is hard to kind of maintain and update and this kind of thing, and evolve, and then the microservices world, much, much cleaner. So all of the cloud services that we deploy in IBM are that kind of shape. A lot of the products that we're selling these days are also that kind of shape because we tend to do things on, orchestration environments like Kubernetes, and we will still use microservices just so we don't end up with a massive, great blob of data. And of course, we're kind of selling middleware, and then when we're building a business application, it makes even more sense to do it like that. But it's, that style of building applications is really very, very common. Now, what people tend to do when they start with microservices is build REST interfaces around everything. And then you end up with big, long call chains, and potentially very long latency as you go from one microservice to another. And even worse, if you're calling out to something which has a different kind of maintenance window or something like that than you're used to in your own business, then you kind of break the chain when you get an outage at the end. So it's a good idea to build some kind of buffer, some kind of asynchronicity, I suppose, into situations like that, just to kind of make it all a bit more manageable. Now, historically, business applications tended to be quite data-centric. Okay? So they would put everything in databases. So the data was kind of essentially at rest. And you would back up your database. You would, the priority was to make sure that you always had a valid copy of your data. And everything was kind of very locked down and transactional in nature and that sort of thing. And your business was essentially in your database. But that's a kind of very static way of looking at things, and it doesn't really lend itself to responsive applications that are kind of give you information kind of in the moment. So another way of looking at things is event-driven, kind of event-based, essentially, where the data is all in flight. Okay, it's all flying around between the pieces of software, and the first priority is that the system remains responsive. Now, of course, this is much more chaotic, and it scares the hell out of people. So you probably get a blend between these two things, but if you wanted to build a kind of responsive application, you kind of need some event-based stuff in there. So for example, imagine that you have a banking application, and you call an API saying, submit this payment. And it takes a bit of a time to actually complete the thing. And it's not a synchronous call, okay? It says, yes, it's submitted. So what do you want to do? Do you want to poll and say, is the payment complete? Is the payment complete? Is the payment complete? Or do you actually want an event coming back to tell you when it's done? Well, certainly I would rather have the latter of those two. I want, a notification on my phone, for example, as soon as the thing's happened, and I don't want it burning the battery of the thing while it's trying to work out when it's done. So that's an example of a kind of responsive interaction, which is event-driven. So this is a kind of a very high-level diagram of what a microservices application might look like if it has a combination of APIs and event-driven concepts in it at the same time. So, of course, the tooling and the kind of ecosystem around REST APIs and microservices is very well developed with things like Istio, and providing service discovery and ways to do A/B testing and that kind of thing. And in comparison, the event-driven world is a bit less kind of mature, I suppose. But what you typically will have is something which I've called on here an event backbone. So this is a messaging infrastructure you have at the middle of your application, and it provides a way of wiring together your microservices. And you'll typically use the publish-subscribe model for messaging. I'll explain a bit more about what that means in a minute. But it's kind of, it's the loosely coupled way of doing communication, essentially. So In some situations, you'll have APIs between your microservices, and in some situations, a microservice might publish an event, and other microservices are subscribed to that event, and they can respond as a result of it, right? So you can do different messaging patterns, so we've got a 1-to-2 kind of communication here, which is, of course, better than having kind of this one calling 2 REST APIs sequentially, because if you want to change your topology with this, you just add a subscription, you don't need to modify the sender of the data. Now, I think in practice, you probably will build a microservices application using the combination of styles. So a good way to think about it, I think, is to have the kind of the big lumps of your application talking to each other with events, and then within each of the microservices, maybe using REST APIs, because they're really nice and kind of easy to reason about, easy to code, essentially. So if you atomized everything into tiny little pieces and used messaging everywhere, then I think you would find it was really rather difficult to maintain. So I said I would explain a little bit more about publish subscribe. So messaging is a way of communicating between programs by sending messages. Okay, so you have what I've called on the chart here, producers of messages and consumers of messages. So the producer sends the message and the consumer receives it. So there are essentially 2 very high-level models of doing this kind of communication. The first one is called point-to-point. So this is a JMS term from the Java messaging service, probably 15-year-old standard, but this is how they divided it up. And with a point-to-point way of thinking about things, you use a queue as the intermediate kind of structure. Okay, so the producer sends a message onto a queue, you end up with an ordered list, and then the consumers pick the messages off, but each message is consumed by a single consumer. Okay, so this is a good way of sharing this set of messages, but not really a good way of kind of spreading it out across multiple things that you wanted to process. So the alternative way of thinking about it is called publish subscribe, and instead of having a queue in the middle, the thing is called a topic. And in that situation, you could have multiple subscriptions to the same topic, and each subscription gets its own copy. Okay, so in this case, every message is processed once. In that case, because I've got 2 subscriptions, it's processed twice. And I could have 1,000 of them or however many. But it's a good way of kind of fanning out information. And this is the loosely coupled way of doing it, of course. Because I can add a subscription after I've built my application and kind of add a new consumer of the information and kind of enhance an application without changing the producing side of things. So how might I do this in practice? A very kind of popular way of doing publish-subscribe messaging at the moment is an open source project called Apache Kafka. Okay, so I expect most people have heard of Apache Kafka if you haven't actually used it. But it provides publish-subscribe messaging kind of at great scale, but it does a little bit more than that, right? It's got support, very good support for what's called stream processing, and I'll talk a little bit more about that in a moment, but this is a kind of an optimized way of processing sequences of events. And it also has a very kind of strong storage infrastructure as well. So most messaging systems have not particularly good support for an enormous amount of data within them. They're very good at handling the data while it's kind of flying around, but when it's kind of static and it's kind of getting a bit older, then they don't really want it in there because it kind of needs indexing and that sort of thing. Whereas what Kafka does is it expects to have a lot of data behind it. It doesn't know very much about it, so it can kind of cheaply hold terabytes of data because it just, essentially, the positions of the application are stored rather than some kind of index about the messages. So it makes it quite cheap to have a lot of data within it. And some of the microservices patterns that you might use for event-driven microservices benefit from the fact you can have an enormous store out there, essentially. And you can see that the terms I was using earlier of producer and consumer, they apply to Kafka as well. So these are kind of general message processing terms. Now, there are a few other things that you can do with Kafka as well. It's got these idea of connectors. So if you want to get events into your system from an existing system, then you can kind of plug other systems into your Kafka and then generate events like that. You don't have to kind of rewrite the world in order to do it. And then there's a higher level API for stream processing off to the side as well. So let's start off by kind of introducing what the event backbone is kind of for. So in a very, very simple case, I've got a pair of microservices here. One is a producer of events, and it publishes an event onto the event backbone. And there's a second microservice which is consuming. It's got a subscription to the same topic, and it gets sent the event. So we've now got these two kind of loosely coupled and communicating. And Because this is asynchronous, of course, the execution rate of these things can be different, okay? You need to be able to process all of the messages in aggregate at roughly the same rate, but if you have kind of peaks and troughs in rate on the top one, then they're kind of unaffected. They don't affect the receiving microservice necessarily. You can also perform maintenance on the receiving one without affecting the sending one, right? You can stop it temporarily, upgrade it to the next version, restart it, and it can just catch up because the messages are in the event backbone. So I mentioned that you would have connectors as well to other systems, so you may have other event sources. So potentially you're writing your new applications in microservice kind of style, and you have your existing enterprise IT systems. If you can somehow feed the events out of those into the event backbone, then you've got data that you can process for your new applications. So you could use, for instance, the change data capture pattern here, which takes changes out of a database, converts them into events, so you get a sequence of create, update, delete, create, that kind of thing. And then these are events which can be consumed by the microservices. So that's quite a common way of kind of linking new and old. Another thing you could do is stream processing, and I'll show kind of an example of that in a minute. So you would think of this as essentially a highly optimized application that might be one topic in and one topic out, and this could itself be thought of as a microservice. Okay? Now, this is more tightly tied to the technology that is used to build the event backbone, but it's still a nice self-contained piece of logic, essentially. People quite often also use some kind of event store or event archive off to the back of this as well. So the idea is essentially that the event backbone can hold a lot of data, but it isn't kind of without limit. You know, you wouldn't really want to store an enormous amount of data in it. So it's probably cheaper to push the older events off to some kind of cold storage, you know, some kind of object store or something like that. So having a link out to that is quite a common way of doing it. And then once you've done that, you have a choice for historical processing, whether you want to take the data from the event backbone or actually to read the event archive instead. And then the final kind of building block in here is, well, what about notifications? So in the example I was talking about earlier with my phone getting a notification when I finished a banking payment, for example, then this is exactly the kind of way it would work. You would have an application number 4 over there subscribing to a topic. An event turns up on the topic saying the payment's complete, and then it issues a notification using one of the mobile phone notification networks, you know, APNS or something like that. Right. So let's look at a very simple example of stream processing. Now, I was doing a talk to and somebody was in the audience from a banking kind of background, and they kind of raised their eyebrows when I did this. But they just told me they'd invented a new REST API which needed to be event-driven, and it wasn't. So I did exactly the same back at them, right? They ended up building polling into a brand new REST API, which seemed particularly insane. But let's imagine that you've got your existing transactional system, okay? And what you're going to do is you're going to build something that looks for suspicious transactions. Okay? This isn't done kind of in line. You don't want to slow down all the existing systems. You want some way of kind of doing it off to the side and adding value without disturbing the existing systems. So what you could do, for example, is you could take a feed of the transactions onto a topic in the event backbone. Okay? And then you've got some kind of stream processing application which looks for suspicious payments. So maybe this is a repeated payment when you wouldn't expect it to be normally, or it's much bigger than you would normally expect, or it comes from some kind of unusual country which you don't normally pay, or something like that, something which is suspicious. But you're putting the rules into this kind of application, maybe by configuration, so you can kind of tailor it over time. And this is a stream processing application, so it's optimized for going from kind of topic to topic. So it will use, you know, techniques such as pipelining and maybe batching for transactions and that kind of thing in order to run more efficiently than just a regular application. So what we're doing is we're taking a topic here with all the transactions, and we're deriving another topic with only the suspicious ones. Okay, so this is sort of duplicating data, but you're kind of filtering it on the way through. And if you're doing this with Kafka, then this can run really, really very fast. It can scale up in a very nice way. So this is one of the reasons why Kafka is kind of good as the event backbone. So now we've got the alerts. We now need to tell the user about them, right? So again, you could use a stream processing application here. And what this second one would do is it would look at the preferences of the customer. So if an alert an alerting transaction turns up for me, for example, I'd like an alert with a push alert, right, rather than an SMS, for example. So it's got a table of customer preferences off to the side, and then it republishes the events onto one of the 3 topics depending upon the notification preferences. Okay, so again, we've kind of gone for a big wide topic to a narrower topic, then to 3 narrower ones. So this stream processing application has gone from 1 topic to 3, and that's perfectly fine. It can do that kind of thing perfectly happily. And then, of course, we have some kind of applications that subscribe to those topics, and then they're either calling SMS API or sending an email or calling the push notification service for the mobile provider. All right, so that's a very, very simple kind of way that you might build a stream processing microservices application, because these are still microservices, right? They've got a well-defined purpose, and their interface is defined by the topic, okay? The format of the message on the topic is going to be constant for every message on there, and that's a bit like the interface to a REST API. So actually jumping into all of this for the first time is perhaps a little bit daunting. You know, what on earth should the events be, for example? Well, that's a pretty good question, I think. So there are techniques for doing this, and one of them is called event storming. Now, I've got a link to an IBM web page on there. Doesn't mean you need to pay IBM for this. This is something you can do yourself. It just happens that we've kind of written up how to do it quite well, so it's a good place to kind of go and understand what it means. But essentially, it's a very kind of social activity. So you might get kind of 6 or 8 people into a small conference room or something like that, take out all the chairs so they all have to stand up and talk to each other, give them a bunch of colored post-it notes, because the colors matter, right? And get everyone to kind of interact and write, essentially, because this should be a kind of an opportunity for people to kind of get all their thoughts out there in a kind of non-confrontational way and try and build a view of the system. So what you're trying to do is essentially work out what the events in the system are, who the actors in the system are, and then what the commands that the actors are actually going to perform, and then which data they need, essentially. So you might, for instance, line up all the events in order, say, you know, first this happens, and then this happens, and then that happens, and you'll build a kind of a time-based picture of the way the system works, and then you would eventually tease out the way that this all hangs together. Now, you may well end up with far more kind of events than you would expect having done this, and, you know, far too many kind of business objects, essentially. So you might go back in the other direction at that point and kind of aggregate them, right? Because you don't necessarily want 1,000,000 different things when actually 1,000 would be more efficient. So you would tend to re-aggregate things into more kind of manageable chunks after you've done that. And then at the end of the day, what you've got is you've got a set of potential microservices with the events that they want to respond to. And then you can kind of start implementing little pieces of the infrastructure. Because I think, you know, you could do a big bang kind of deployment, but it's probably rather more sensible to do something in a measured way to start with. So here's an example which is a little more kind of realistic. So you can see the code if you follow that URL down the bottom there. So there is actually running code behind this. It's just kind of an example of how the application would work. And the idea is that this is a kind of a shipping container system. Okay, so you've got boats that you want to fill up with orders and then kind of send them across the seas to deliver things to the receiving customers. And of course, you want to kind of fill up a boat, and sometimes you might try to put things on which won't fit, or you know, something like that. So it is kind of event-based, and there's a set of microservices in here as well, right? So, for example, there's an orders one, and there's a voyages one, and there's a containers one. And this is kind of the flow of the events as they go through the system, kind of the way that the orders progress. So what might this look like in practice? So, for example, I've got 4 microservices as a result of that, and I've just colored them differently to make it easy to see what's going on. And a couple of them have REST APIs, because these may well have a kind of user interface on the front of them which you need to poke when somebody presses a button, right? So an API is quite a good way to kind of start that, but it may result in a flood of events from that point onwards. And they need some kind of storage behind them, potentially. Now, this might just be in memory, but it's quite common that you'd actually have some kind of microservice-based store behind it as well. And then if you're doing it in an event-driven way, then I imagine you would actually have one topic for each of the microservices as well. It might be more complicated than that, but in the simplest, you know, kind of way, I think you'd have microservice, some kind of storage, and then some kind of topic behind it as well. but there may also be more kind of derived ones. So for example, maybe we've got some piece of analytic software which looks at ships and containers and goes, well, this just doesn't make sense, and then it raises a problem with another topic. So this is an example of streaming analytics, subscribing to both of these and providing some kind of join capability and then raising alerts. So this is fine, but I'm sure you can see that there might be some kind of complexity to breaking up the world like this. So you definitely want loose coupling, okay, because you want to be able to stop and start and evolve things independently. So this is a really nice capability, and using publish-subscribe messaging is a really good way to do that. But there are some more complicated things to achieve with this model. So one of them is data consistency. So in a microservices application, you often find that the world is, or the data is handled in an eventually consistent way. Okay? So by that I mean that you kind of start making an update to a piece of data, and actually it kind of trickles through the system gradually, and eventually everything is consistent, but you kind of have to wait for it to happen. And that model is certainly true for lots of the kind of the cloud-first data stores. You know, they kind of replicate asynchronously between the nodes, giving you availability and performance, but at the cost of some kind of data integrity. And also, if you're used to monolithic applications, they tend to be properly transactional, right? Everything is done in some kind of transaction monitor or application server, and you tie your databases to queues together, and you do two-phase commit and this kind of thing to make sure everything is totally, entirely consistent. But the problem with that is it doesn't really scale, and you've, of course, built a monolith. So when you start breaking everything up, then you do end up with data consistency issues. So how are you going to manage data consistency in this world? And then the final one is, well, what about efficient queries? I've published all of these events onto a topic. How do I find out, how do I query a piece of data out of this? Well, if you're doing it in an entirely event-based way, you start at the front of the topic and you hop along it until you find the data and you go, I've got it. But the more data goes in, the less efficient that goes. So you kind of need other ways to make this sensible, essentially. So you could invent everything from scratch, and good luck with that. It's going to take quite a bit of time, and you're going to make lots of missteps. Or you could try using some patterns people have already tried, and then learn them well, and then kind of apply them properly. So I'm going to go through a few of the patterns which we kind of see and recommend here, just to kind of illustrate ways that you could do this. So the first one, and this is not necessarily just for event-driven microservices, is database per service. Okay? So I sometimes see people who've said, well, we're going to a microservices architecture. Of course, everyone is using the central database. And of course, they haven't got microservices at all. All they've done is they've kind of introduced a bit more chaos, and everyone is still dependent on the database schema. So if I modify the database schema, I modify every application at the same time. And this is just ridiculous. You haven't really made any progress at that point in time. So a better way of doing it is to give each microservice its own store of data. Okay? Now, it could be a database of its own. It could be something like MongoDB. It could just be some kind of in-memory table, something like that, but still something which you can kind of query. Now, if you're using Kafka, then there's another thing you can do. So there's this concept in Kafka called stream table duality. And what that essentially means is if you have a topic which has kind of key value data on it, you can treat it like a table and run queries against it. So if you're an entirely Kafka-based kind of shop, then using Kafka streams and K-tables, they're called, is potentially one way to do this. So that would be one way to implement a kind of a little store using particularly Kafka. So doing this is kind of fine, but of course what you've done is you've said that, well, I only have to change my microservice when I change the schema of this, so this is very good. But of course, you've kind of, how do I get consistency across these things? Because I've kind of taken my own copy of the data, and if I make a kind of a change in this one, and I need a change in that one, how do I actually achieve this? Well, that's one of the problems in here, and the the Saga pattern is one way you could potentially address that. So Kafka actually is helpful in another way in this environment, and that is if you're trying to make these kind of copies of the database and have each microservice have its own kind of derived copy of some kind of central database, it can actually do this kind of filtering and data replication job for you. So this is using the change data capture pattern. So we've got what I've called here a source change log. So this could be the recovery log from a relational database, or some of the other stores actually have ways of publishing out changes when they get made. And they're read by a messaging producer application. So this is an application producing events onto the event backbone. And then it publishes the events onto the backbone. And I've called this a topic partition. It'll be clear why I've called it a partition in a minute, but this is essentially a topic, and these are key value-based messages now. So the key would be equivalent to a primary key in a database table, and the value is all of the row data. Okay? And then they're written in order in that direction. So this is the first piece of data for key A, and it is actually superseded by A2. So this is not a delta. That's maybe a creation, and that's an update, but it replaces this one here. Okay? And then key B, I've got an original value, and then I've got a null value here. So that's equivalent to a deletion of a row. Okay? And then for C, original value, and then new value. And then I have a consuming application down there in orange. And what it's doing, of course, is it's reading all of these events, and it's making its own derived table. So maybe there's 15 columns in the table over here, and we only care about 2 of them over here. So what we do, of course, is we crunch the data and write it onto our own local store, and then we've got a private copy of the data, which is for use by this orange microservice alone. Now, of course, it's asynchronous, okay? So this is being updated transactionally, and then it's going through the event backbone and then out into the consumer, and it's kind of eventually going to be taking the data. So you have an eventually consistent store, but one which gives you the property that it's kind of independent, and the format of it is not going to be perturbed by people changing things up here. And a couple of other things about this. This keeps up to date automatically, okay? It's an evolving view of the store, because when this changes again, another event turns up on here, and it's consumed by the consuming application, which modifies its store. So you've got an evolving copy of the store, naturally, because it's a kind of publish-subscribe messaging application. And of course, the final thing is, because it's pub-sub, I could have 10 of these things off the back, each taking their own copy, and each doing their own processing to make something which is subtly different, but tailored to the particular microservice. Now, this is fine, but of course, this thing grows without limit, okay? So it will soon take up all of the disk in the known universe. And we don't really want that. So what can we do to actually stop this from happening? And again, this is why Kafka is particularly useful in this case. It's because it has this idea called log compaction. So if you have one of these key value-based topics, then you can tell it to periodically kind of crush it down. And what you need, of course, is you need the latest value of each key only. Because A1 was superseded by A2, you no longer need A1 once A2 is written, so you can just eliminate the others. So you end up with a kind of a topic with gaps in it, which exactly matches the table over there. So this is kind of an automatic thing that Kafka can do. If the number of keys gets ridiculously large, like in the millions, it's not suitable anymore. But if you're in 100,000 kind of range, then it's entirely acceptable to do that. Okay? Right. So another pattern is called Sagas. So the idea of a saga comes from, I think, probably the 1990s. It's a kind of, originally for kind of more exotic transaction processing. So the idea is you've got a sequence of transactions that provide some kind of bigger, higher level business purpose, okay? And each of the pieces is a separate transaction that is entirely atomic. And you chain them together, and if you get a failure in it, you kind of run compensation logic to go backwards and undo the effects of the first thing. So you're building something which maybe lasts rather longer and rather more complicated. And this kind of idea has been kind of borrowed by people building event-driven microservices. So what you're trying to do is you're trying to orchestrate a set of multiple steps across microservices so that eventually you complete the entire job. All right? And of course, this is eventually consistent again, and in some ways kind of a little bit scary. So I'll just kind of explain what the diagram is showing, and then I can kind of explain how people actually achieve it in practice. So the orders microservice has published a message onto its topic, which is message number 1, and the containers, fleet, and voyages microservices are all subscribing to that topic. And so it might be, for example, order created, and the other 3 microservices leap into life and they go, well, I've got to do some work now, so they go off and do it. So the containers microservice does some work, and then when it's finished it publishes a message saying, I've done mine. And then, of course, the fleet one and the voyages one do the same. And the orders microservice is subscribing to all of these, okay? And when it gets a message from each of them, then it makes a state change to say, well, now the order is complete, okay? So that's kind of how it works in the happy path. Now, if something goes horribly wrong, then it all gets a bit more difficult. You might need to back out. So you might, in practice, have to build timeouts or something like that in there as well. Now, people will typically, not always, but they will typically build this orchestration logic actually into their microservices. So this is kind of a little bit complicated and a little bit kind of fragile, perhaps, but this is still the way that people tend to do it, right? So they will build a subscription to the containers microservice into the orders one, and then they'll say, well, when this fires an event, then I need to take some action in here, okay? Another way to do it is to use some kind of workflow engine. Okay, so there are workflow engines being built on standards such as BPEL and BPMN, for example, where you're describing in some kind of specification document a multi-step process, and then each of the pieces would be kind of one of these. So that's another way of doing it. But I don't see people doing that in microservices typically. If they already have skills in that, then maybe they would. Otherwise, they tend to build the code straight into their applications instead. So, another pattern which people quite commonly use, or I think probably more correct to say they talk about it quite commonly, is called event sourcing. Okay? So this is a simple example of event sourcing. So what you do is you essentially say, every change to one of my objects becomes an event, and I write it into the event backbone. Okay? So then I end up with a kind of a history or an audit log of my entire business in terms of the events which were which happened. And then if I replay all of the events in order starting from the beginning of time, of course, I've recreated my business. Now, the difficulty is, of course, the longer the business exists, the longer it takes to replay them. So it kind of grows without limit. So there are complexities to doing it in practice because of the space it takes and that kind of thing. But as a kind of a model, it's really nice and very clean. So, for example, I've got the user here calling an API, which is handled by a command handler, and the command handler then publishes events. So I've got order 1, which is created, and then updated, and then complete, and order 2, which is created, and then cancelled, and order 3, which was created, updated, and then complete. And then I can have some other component, maybe part of the same microservice, some kind of microservice perhaps, which is processing these events and then making some kind of rolling them up somehow into a way that is easier to query. Because of course, if I'm just using the topic and I say, what's the status of order 1, I have to read all the events. So what I really would like is I'd like to kind of roll them up into some kind of more kind of consumable way. Now, in order to kind of get atomicity in here, this is kind of a little bit tricky, interesting, I suppose. So what people typically do, and this is kind of a convention that the application designer typically chooses, the normal way to do it is to say, publishing the event is an atomic action, okay? So each event at a time is one kind of unit of atomicity. And then the downstream processing of it doesn't need to be atomic at this point. You essentially, the processing performed by the query handler is idempotent, okay? So it can do it again and again and again. So what it can do is, it can be reading these events, and if it crashes and then restarts, its position is still back here, so it can kind of have another go. And it only actually moves forward its current, its kind of restart position when it's sure it's completed what was over there. And in the unlucky event that you lose that store, you can, of course, reprocess all the events at that point. Now, I mentioned earlier about this idea of having an event archive or an event store off to the side of the backbone. Well, that would be one situation where potentially you wanted to keep the entire audit log forever. So putting it onto cold storage and only keeping the more recent ones in the event backbone is probably a good way of doing this. Another way people handle this is periodically they take a checkpoint. Okay, so what they do is they kind of roll up the current state and then write that as an event, and then you can throw away all of the previous ones. But of course, if you wanted an audit log, you've lost that ability, but you have gained some kind of efficiency as a result of doing it like that. Now, this is another situation where the way that Kafka works is really a very good fit for this. Okay? So it has this way of being able to store data for a long time, so that's nice. But it also has a way of distributing the workload across multiple applications that fits very well with this. So, excuse me a second. I've realized that I've got my animation slightly wrong. All right, I'll have to fix that later maybe. So what I've got here is I've got 3 separate partitions of a topic, okay? So these are one topic, but with 3 separate lists of messages, okay? This is just one of the things that Kafka can do. So this enables you to run a topic across 3 servers simultaneously and maintain order. And what you may notice here is that the order number, 3333, all of these guys are in the same partition, okay? And we've got no kind of crossover where you end up with one order being in 3 of these things. So what that means is, if I can process one of these lists, I'm going to get a consistent view of a particular order, okay? And if I process another one, then I get a consistent view of those. And I can spread out the workload across multiple consumers in order to make it go faster, okay? So we've got ordering and scaling because of the way that Kafka works, okay? So, for example, I'd get the top consumer to process that partition, and the second consumer to process that one, and the third consumer to process that one, okay? And because this is publish-subscribe again, I can actually have 2 different processing kind of sets called consumer groups processing every event. So this might be 2 different microservices, right? It could be the orders one and the fleet one, for example, right? And there's no requirement here that I have exactly the same number of consumers as I have partitions. If I have fewer consumers than partitions, I just kind of get one consumer processing multiple of them. But I've got workload balancing and ordering at the same time, which is a really nice feature. Right. So the final pattern I'm going to talk about really rather quickly, because this one is hideously complicated to achieve in practice, and it definitely is true that more people talk about it than achieve it. And that's called CQRS. Okay? So the idea is essentially that you divide the application. If it's a CRUD application, you do the mutating operation, so the create and the update and the delete, using one side, which is called the write model, and you do the reads on the other side, which is called the read model. Okay? So this is optimized for writing very quickly, and the read-optimized store may be really quite different, okay? So it probably has an index on it, for example, and it may actually join pieces of data to provide some kind of query across various entities which kind of answer a business question rather more efficiently. So I've seen somebody do this, not exactly like this, but definitely build a store off to the side, which was for running their kind of once-in-a-lifetime or once-in-a-blue moon kind of queries. But in practice, this is really quite difficult to achieve. Kind of maintaining consistency or sufficient consistency between these 2 things is really pretty difficult. So this is definitely one where people go, well, yeah, this would be really cool, but it's really a little bit hard. So I think what I've done is I've shown you that event-driven microservices give you an effective way to build loosely coupled applications, okay? Just by making the communication asynchronous for the big lumps of this means that you get the ability to perform maintenance on these things independently and scale them independently. You get all the benefits of microservices, and the fact it's asynchronous means that it's kind of more loosely coupled. Now, if you wanted to actually do this in practice, then use a technique like event storming to get started. Okay, for one thing, it's going to be kind of a fun morning. It's counts as work, you get paid for it, but you're standing up behaving like children. So this is kind of a good thing in my book. And then, if you were to try and doing this, then use patterns like event sourcing and Sagas to build on things people have already found to be effective and make it kind of manageable rather than kind of chaotic. So, are there any questions? I find it quite hard to see past the lights, actually. I don't know how this works. Do we have a microphone that people wander around with, or do I just have to walk around and listen? Okay. Right, was there a question back there? No, okay. All right. Thank you very much.